Assalamualaikum warahmatullahi wabarakatuh and greeting everyone. My name is Muhammad Khalis and I will cover on the laboratory safety course in physics lab. As we acknowledge the hazards and risks are everywhere, there are precautions for all of this, especially when you work in laboratory. But once the incident happens, it cannot be reversed and the effect cannot be undone. That's why we are going to talk a lot on hazards today, mainly from the physics laboratory. But the course is not cover most of the instruments. It's just for you to get an idea how to determine the potential hazards from your instruments. So when we work in the lab, we are constantly exposed to hazardous chemicals, electrical shock, pathogenic biological material, and the radiation hazards. And all of this has their deterministic effects. It is very important for us to have a safety measures, and we should follow it while working in the laboratory to ensure the safety of the workers, especially you. But why must we conduct a safety laboratory? Because we want to fulfill the safety, health, environment aspects for all laboratories in the faculty. Actually, we are under the laws of Malaysia, under the Act 514, Occupational Safety and Health Act in 1994. So one of the regulations states in the section 49 bracket 2 of the OSHA 1994 state that person who without reasonable excuse fails to comply under the section 48, probably the section 48 talking about the safety and everything on the how you manage the safety, you be able to be fined not exceeding 50,000 ringgits or to imprisonment for a term not exceeding 5 years. That's a very sad right if we penalize like that. So the most important, the rules must be always followed. Okay. So there are hazards around us. There are lots of hazards, and also the risks from these hazards: chemicals hazard, radiation hazard, electrical hazards, pressurized gas hazards, and the fire or the heat is also the hazards, especially in physics laboratory. So when we work with chemicals, there are some chemicals actually are very reactive and easily vaporized. So we understand that when it's vaporized, it cannot be seen, touched, or smelled, but it is very hazardous. Sometimes we inhale it. We take over 20,000 breaths a day, and if we work in the laboratory and these chemicals or pollutants we inhale actually can end up in our lungs and bloodstream. Sometimes these chemicals, for example radon or carbon monoxide, are odorless, tasteless, and invisible, yet it is very hazardous. And also to this exposed to the skin and eye, okay, because this skin and eye is a very sensitive organs, and we will see that there's a reaction, fast reactions if we touch or expose to some of the chemicals, especially in this skin and eye. And also if we bring the food, water to the laboratory, also you might possibility ingest these chemicals. So don't bring any foods or drinks in your laboratory. As we eat and drink, we don't know, we might swallow chemicals that actually can harm us. So depending on the chemical, there are longer term health effects. Sometimes the longer term health effect we call as a stochastic effects, which include the organ damage, the weakening of the immune system, the development of allergies or asthma. Sometimes there will be cause reproductive problems and also the birth defects. It also affects the mental, intellectual, and physical development of the children. And the most important thing is it also can cause the carcinogenic effect, which is cancer. We want to avoid this. That's why in working in laboratory, you have to protect yourself from the chemical hazards. And also in physics laboratory we have this kind of radiation hazards. There are two types of radiations. We have ionizing radiations and non-ionizing radiations, but mainly we are focusing on ionizing radiation, because ionizing radiation is the most harmful, because it has a sufficient energy to affect the atoms in living cells and thereby damage their genetic materials, which sometimes could cause these carcinogenic effects. But even the ionizing radiation could give detrimental effect to the DNA, but our bodies sometimes are repairing this damage. But sometimes when they are repaired, suddenly the cells cannot be repaired correctly, and the cell actually are mutating and will become cancerous. So there are two types of health effects you could see from the radiations. There is deterministic effects or the stochastic effects. Deterministic effect, you could see some acute health effects such as skin burns, erythema, and acute radiation syndrome. Meanwhile, for the stochastic effects, it's a prolonged. We could see the consequences including hereditary effect, and also the cancerous carcinogenic effect to the cells. That's why we have to protect ourselves from these radiation hazards. There is no exceptions for non-ionizing radiations. Although non-ionizing radiations cannot cause the harmful or deterministic effect on the DNA, but it is also harmful in molecules levels. It actually could cause the detrimental effect to the human tissue. For example, high frequency of UV radiation, ultraviolet radiation, such as UV type A or infrared, actually can cause erythema to the skin, and sometimes it can cause the cataract to the eye, which is very dangerous. Same goes to microwave. Although everyone says that microwave is less harmful, but the cumulative heat from the microwave actually could heat up our tissue, and probably in the prolonged effect the tissue will be weak and sometimes cause the harmful effect to the human itself. So the exposure pathway, especially in ionizing radiations, there are several classifications for these ionizing radiations, and the risk from this exposure actually depend on lots of properties. For example, the energy of radiations. The energy of radiations we could see from the electron volt, kilo electron volt or mega electron volts. So the higher the energy, the higher is the harmful, the higher is the effect to the humans. And also the type of radiations. We have a lots of types of radiation. We have 4 actually: alpha, beta, gamma, and X-ray, and all of these has their properties to the effect on the human tissue. And the activity, probably the radioactivity, how often it emits radiations. We could see this especially when you're handling the radionuclide or radioactive materials. So there are two types of exposure, whether it is external or internal. External probably is from the outside of our body, for example X-ray and gamma rays. When X-ray and gamma rays penetrate our body, actually deposit some of energy which could ionize our DNA. And there are also internal exposure, which happen when we ingest or we inhale some of the radioactive materials, and actually this could cause a serious health threat if a significant quantities happen to be inhaled or ingest. So it depends on our body. If our body metabolize very well, the radionuclide might excrete away. Okay, if it's happen to deposit in our body and staying for long, there is probably is a harmful effect to the human or tissue. And again, there is another hazard which is very important also, which is called as electrical hazards. because all of our equipments or instrument work using the electricity. So when we deals with the electricity, incidents do happens, and we should have a safety rules, right, of electrical conducts applies to all work activity in such proximity to electrical systems. These electrical hazards may cause death or personal injury, especially from electric shock, electric burn, electrical explosion, fire or explosion which is initiated by the electrical energy. And the risks include electric shock and burns from live wire contact, because probably there's a fires from the faulty wiring, overload circuits, electrocutions, or burns from the lack of PPE, protective equipment, explosions and fires from explosive and flammable substance, contact with overhead power lines, and sometimes when these instruments or electrical equipments are exposed to the water, also can cause a hazard risk. I'm sure you all understand the general safety of laboratory. Actually, you may refer from the safety guidelines from the laboratory you work at, but I would like to highlight some of the most important. For example, you have to avoid skin and eye contact with all exposures, especially from chemicals and radiations. You have to ensure you use the equipment only for its designated purpose, and not altering something, like you become MacGyver in your laboratory. No, you don't have to do that. And of course, you cannot consume or bring foods or anything, apply cosmetic in areas where hazardous chemicals are used or stored. This is always happen in most laboratory. Actually, this is not proper. It's very bad. Don't do that. Okay. Now, before we proceed with the next topic, please kindly scan this QR code. Welcome back. Thank you for scanning your QR code. It is for your attendance for this session. Okay, let's continue. So the hazards in our laboratory mainly comes from our instruments, because our instruments utilize high energy of electrics. It is high voltages, high currents, and the source mainly for these instruments are electron and X-ray, which is hazardous and may cause harmful effect. And of course, we have this furnace, high temperature furnace, which could produce up to 3000 degrees Celsius. So lots of our equipment or instruments in our laboratory is very hazardous, and it's important for us to be cautious of all these potential hazards. So again, there is possible hazards are different between instruments. You just have to make sure that all equipments are in working conditions, and please follow the manufacturer's equipment handling and also the maintenance rules. So let's see our first instrument. It is a Fourier transform infrared spectroscopy. So in infrared spectroscopy or infrared radiation, it is passed through samples. Some of this infrared radiation is absorbed by the samples, and some of it is passed through transmission. The resulting spectrum represent the molecular fingerprint, molecular absorption and transmission, which create molecular fingerprints. And like any fingerprint, there is no two unique molecular structures produce the same infrared spectrum. That's why the FTIR becomes very important and useful for several types of analysis. But again, since it uses infrared, it is a kind of a non-ionizing radiation. It has to be cautious. So you need to take safety protocol. Okay, ensure the safety protocol is followed. So first, when you move the samples between the preparation area and the spectrometer, the care must be taken to ensure the sample is sealed and the vessel exterior is clean. So please ensure that detector and beam splitters either is need to be changed or cooled, and if there is a laboratory assistant, please allow them to help you to use it, to guide you before you proceed with the assessment or measurement. So during the process there are light produced in the missions, so it will affect your eye, so the safety goggles should always be worn, and no attempt should be made to open the spectrometer while under vacuum. This is very dangerous. It will harm to you and also harm to your samples. We don't want that. And of course, when we use this infrared detector, which is we use the liquid nitrogens. So liquid nitrogen usually from the cryogen, so the cryogen general precautions must be followed. So you need to use insulated gloves and safety goggles, and also the area of this FTIR should be well ventilated. Okay, and then the second one is the instrument is a scanning electron microscope, or ACM. The ACM is a microscope that uses electron instead of light to form an image. The SAM has advancing new areas of study in the physics as well as medical science communities. The SAM has a large depth of field which allows more specimens to be in focus at one time. The SAM has a higher spatial resolutions, so closely spaced specimens can be magnified at much higher levels. So the SAM uses electron, and these electrons are produced from the electron gun, and these electrons will travel and will focus to the beam down toward the samples, and once the beam hits the samples, the electrons and X-ray are rejected from the sample due to characteristics and the Bremsstrahlung operational. And then there is a detector, and this detector will record all the informations from the scattering informations. So again, because it uses light charged particles, and also probably there's a X-ray produced during the process, so most of our SAMs are designed with the shielding purpose, the shielding area. So it will prevent us from the exposure rates which higher than the background readings. And also while we are opening, there is a time delay in chamber, venting, and also coupled with the rapid dissipation of radiations, which will stop the hazardous radiation being present during the opening. So the SAM also uses higher voltage and higher currents, so no exposed live electrics are present under normal circumstances because it's well protected. It has this kind of insulator. That's why. But once insulator is break down and everything, so we have to be careful. And also there's a vacuum system, and mechanically this vacuum system is very important. If it fails, and again the SAM cannot be operated. So when you prepare the SAM, please ensure to follow the guidance. And also the shielding we talk about, the shieldings are sufficient to maintain the exposure rates less than 0.5 milliroentgen per hour at 5 cm. It should be complied. If it's not complied, then we need to get the SAM to be checked. Okay, and also there is some ergonomic issue during the using the SAM, because probably you will sit for so long, and the prolonged sit is not so good. You will feel awkward and also uncomfortable posture, and also the eye strain, because sometimes you use the eye looking at the monitors too much, and you will burn out. So please ensure that you have a rest during the process. And the operational equipment is more on the mechanical, for example interlock, the operational button, just make sure it's fine and we can go for the analysis purpose. And then the third one is a inductively coupled plasma mass spectrometry, or ICP-MS. So again, the ICP also use ionization source that fully decompose a sample into its constituent elements and transform these elements into ions. So the ICP-MS composed of argon gas, and energy is coupled to it using an induction coil to form the plasma. So numbers of hazards, numbers of caution you need to look at when you use this ICP-MS. First, the electrical hazards. The power of supply of ICP-MS is extremely highly voltage, and it is advised to not disable safety devices and interlocks. This instrument also can expose leaf components, and the capacitors inside the instruments may remain charged even after disconnection. So we need to be alert of this. So therefore, the instruments can remain potentially dangerous due to presence of residual high voltage. And also the ICP-MS, when it's operate, the surface become hot because there is a plasma produced inside the machines, right? So please avoid touching any component marked with hot surface symbol and allow some time to cool down. During the operation, please ensure that hot and corrosive gases are being efficiently vented from the exhaust ducts in the back of the instruments. Okay. And also the ICP-MS generates high intensity of ultraviolet radiations, where sample compartment is provided with a protected window for safe viewing of the plasma. Usually it's already illuminated, right? So we could see from the outside how the plasma is produced. And also there is a safety interlock which automatically shuts off the plasma source if the sample compartment is open. It's like open, when you open, then the plasma is shut down. So the protective UV eyewear is recommended, as direct viewing can lead to permanent impairment of eyesight. So you don't have to look at the plasma, you could do anything else, just let the machines work. And also the chemical hazards, again, when you prepare the samples, you use a highly corrosive acids, so that's why it is important for you to follow the SDS. The SDS is like a guidance when you handling with these chemicals. Okay, and then this is a XRD. XRD also uses X-ray. We call this as a X-ray diffraction analysis. XRD is a technique used in materials science to determine the crystallographic structure of a materials. XRD uses the X-ray and then irradiate the materials, and then they measure the intensity and the scattering angles of the X-ray that leave the material. It's like same as a FTIR, unless the FTIR is involved with the IR radiations. Now we want to look at the crystallography. We use the X-ray, and this X-ray could interact with the atom and scatter some of the informations. It's like a fingerprint. It's like a fingerprint in terms of the crystallinity of the materials. So when it's scattered, the X-ray is scattered. The scattering is known as elastic scattering, and the electron is known as the scatterer. The regular area of scatterers produce a regular area of spherical waves. Because the XRD uses the X-ray, so again the safety is a must, because the X-ray, the ionizing radiation, is licensed by the Atomic Energy Agency. Compared to non-ionizing radiation, there is no license for that, but there is license in terms of electrical power and so on. But when you use any ionizing radiations, it will be licensed. So when there is a license, means there is a enforcement, and as an enforcement there will be a penalty. Again, the penalty here in X-ray is very very costly. Okay, so please ensure that all the operational machines are intact and still operates in good conditions. Sometimes SRD has this it's like a stopper, it's a stop loss. When you want to push, when you have something wrong, then you can shut down the electrical power, so there will be no X-ray. So if there's a problem, please again shut down the unit, and you put some notes to the safety supervisor, okay, to ensure that they are noted that there is a problem with the SRD. Okay, safe samples, of course. You need to maintain a safe environment of the lab, so you have to provide all the informations of your samples, because there's a form there, and you have to write down all these chemicals or formulation that you use. This to ensure that you don't want to pollute the XRD machines, especially the XRD tube and so on. While working in X-ray or any ionizing radiation, we mainly focus on the ALARA. ALARA is the full acronym of ALARA is as low as reasonably achievable. So what do we look at is we focus on the STD, shielding, time and distance. Time, we have to minimize the amount of radiation exposure time, so you don't have to be there while the samples has been analyzed. You don't have to be there, and you have to make sure that the samples are protected. Okay, and shielding, sometimes if you have to handle it, you have to be there with your samples, so then you have to wear proper shieldings, use a lead gown or radiation glass, and also the most important, you have to use the dosimeter. This dosimeter will tell you the amount of radiation that you receive during the availability in the hot area. And also the distance, please keep as far as away. Sometimes you don't have to be there, you just move apart away, and then let the machines work, and then you can take your samples and then bring it for data analysis. Okay, and then we have these ultraviolet radiations. Ultraviolet radiation is an electromagnetic radiation in the wavelength interval between 10 and 400 nanometer. So the UV ultraviolet source used in laboratory include handheld UV lamps, UV trans illuminators, and also the UVVs. These sources usually emit ultraviolet radiation in the region of 280 nanometer to 400 nanometer. So some of the photobiologists, they classify the UV into UVA, UVB, and UVC. It depends. But again, the ultraviolet also is dangerous, but not much dangerous as ionizing radiations. So when you work in the ultraviolet source laboratories, please ensure that all the safe operation is intact. Please ensure the enclosure, especially the use of light tight cabinets, and also the exposure could be prevented. The screen areas, it will be required when the exposure process takes place external to the source housings, interlocks working properly. The shieldings, we have lots of shieldings for the UV, and also the elimination of reflected UV radiations by avoiding shiny surface and using non-reflective UVR material, because we want to protect our eye and so on. And in terms of administrative, again, all staff or students who wants to deal with this ultraviolet radiation, you have to be trained. Okay, and try to minimize the exposure as much as possible using the ALARA concept. Restrict the access, not everyone could access to this UV lab, and also put the hazard warning sign. We could have lots of hazard warning signs so that you would remember and protect yourself from the hazards. So again, in terms of personal, please ensure that all those sensitive organs such as eyes, skin and face are protected. Hands could be protected by wearing gloves with low UV transmissions. Arms will be protected by wearing long sleeve lab coat, a full face visor which are UVR compatible. It is should be used, and whenever the UV source is unprotected. Okay, so where protective equipment is provided for use with the UV source, it must be subject to a regular regime of weekly checks to ensure it is available adjacent to the source, clean and not damaged. And then there is a Raman spectroscopy. Again, this is also famous, used in our physics laboratory. Raman spectroscopy is based on the interaction of light with the chemical bonds of a substance. This yields detailed information about the chemical structure, polymorphism, crystallinity and molecular dynamics. Ramans, again, it also uses same UV light, probably in certain range of frequency. So Raman is a light scattering technique whereby a molecule scatters incident light from a high intensity laser light source. So most of the scattered light is at the same wavelength or color as the laser source and does not provide useful information. This is called as a Rayleigh scattering. So again, when you use radiation, you have to be cautious. Okay, so you have to handle the device at a safety distance recommended by manufacturer. Never look directly into the laser source, as it will burn out your eye. Never point the device directly at the persons. We are not kids anymore. Please work it properly. Avoid scanning dark colored compounds. The laser beam in this analyzer can potentially cause the dark colored substance to burn or ignite if scanned directly. So avoid the dark colored compounds. Avoid scanning sample that is suspected to be explosive or may burn or ignite if scanned directly, because we use a high intensity of laser rays. And then, okay, the last instruments, which is the most famous instruments in the departments of physics, is the furnace. The furnace is a device in which heat is generated and transferred to materials with the object of bringing about the physical and the chemical changes of the materials. The source of the heat is usually the combustions of solid, liquid or gaseous fuels. Probably in our department is gaseous fuels, and also the electrical energy. So in the glass industry, recipirators are used to preheat the combustion air. The hot waste gases and the cold combustion air must be separate. So we will throw out the wall, bring out the wall. So no problem with the gases if you bring out all of the gases. You have to make sure also our furnace instruments are installed in the ventilated place. So design considerations. So we have to ensure the furnace are properly organized, where the power grid to the front, transformer or magnetic tuning sections, there is a separate room for all of this. Okay, so we could prevent from the electrical shock. And also put more safety signage. If you don't see safety signage, please tell us, the supervisors or the laboratory assistant, so that you will be aware of these hazards from the furnace. So conclusions. Okay, please protect yourself in a laboratory settings. There's a lot of laboratory settings, different equipments, different hazards, and also you need to understand the emergency protocols. Okay, know your lab instruments and their potential hazards. Okay, please identify this and bring and because you will work for long, right? You will, after this, when you graduated, also you have to work with all of these equipments. So the most important is you understand and you acquire confidence in using the physics laboratory. Okay, that's all from me. Thank you for listening.